fellow developers, writers, and everyone who loves game design.
Welcome to DLC Not Included, our weekly podcast where we discuss game development, the industry, and everything in between.
We're your hosts, Steele
and Teal. Glad you could join us.
Considering how cold it's been down here in South Texas, especially the Houston area, for the past 3 days, up to and including frost, sleet, almost snow, ice, and power outages, we're really lucky and happy to be here.
Finally, we have some good weather.
Yes.
It's beautiful out there, and it's kind of warming up. It's like 30.
It's that delicious little chili we like, where it's just slightly cold.
Just a bit.
Just enough where we can kind of cuddle up under blankets, drink some hot cocoa, and watch Season 2 of The Witcher.
Yes, that's very specific, by the way.
Very, very specific. We're finally catching up on that. But, the thing is that the weather here is often kind of scary. Mm-hmm. And, having some sense of pattern and some sense of dependency on it helps take away and helps demystify that fear.
Yes.
That comes with, not knowing what kind of ass kicking Mother Nature's going to deliver next.
And that's interesting you say that, Steele, because that's kind of like how our topic is today.
What are we talking about?
We're talking about programming basics.
Yes. Programming, however, let's kind of take away from that fear, because programming is way too huge of a topic for us to just talk about tonight. It takes a long time to master.
Yes, it does.
That's not what this podcast is about. No,
today we're just trying to dispel some of the myths that you guys may have, that it's too difficult for somebody to learn.
Right. We're demystifying it and trying to remove some of the fear that comes with when a developer is told you need to learn programming. Mm-hmm. Because, let's just get it out of the way, you should know how to program. Even if it's a little bit, programming is important.
Yeah.
But let's take it at the highest possible level.
Okay, so let's talk about what programming is and why you should learn it.
Exactly. So if you just heard us talk about programming and your first reaction is to pull back and run and go do something else, we urge you to stay. We're going to take this in very layman's terms.
Yes.
And we're going to make it as easy
and as fun as possible. I say fun in quotes because... Yeah.
It is programming.
Yes, it's programming.
And if you're a programmer and you're going, oh, hell yes, Studio Blue is talking about programming, just understand we're talking about it to people who might be scared.
Right.
Okay, so what is programming? Well, a program is just a set of instructions for a computer. That is all
That's all it is.
People think of programs as these big, huge, nebulous things that do magic. It's just a set of instructions. It's no different than me telling Teal, please get in your car, take the card, get in your car, go down to Taco Bell, get me a bean burrito. Right. That's a program. That's a program that gets me on the couch.
Yeah, but it's still a program. Yeah.
We're going to break down a couple of terms here. You don't need to know these terms by heart, but it's just so if we mention it, you won't be afraid.
So one of the terms that we're going to be talking about is algorithms.
Right.
Okay, algorithms are individual instructions.
Take the card. Mm-hmm. Get in the car. Drive the Taco Bell. Those would be the instruction
That's the individual instructions. Right. Now, you put it all together, and that's the program.
Right. Now, and an algorithm is several sets of pieces. So, for example, when I tell Teal the algorithm of getting in the car, she moves over to the car, she unlocks it, she sits in, she adjusts the mirror, that kind of thing. So, the reason that we're making sure you understand all this crazy lingo stuff is if we reference that, understand that, while you may be creating something that's very simple in your mind, like having your character walk from point A to point B, there's a lot that goes into it. You don't need to know the nuts and bolts of every single thing that goes from point A to point B, but you need to understand that it's not just your character walks and magic happens.
Right.
Okay. Big important thing. Computers can only think in states of on and off or 1 and 0.
Yeah, and that's called binary.
Right. So when we're talking about, again, all this stuff that's going to seem terrifying, just remember that at its very basic core, your computer's stupid. Yeah. It can only do what you tell it to do, and it can only think in states of yes, no, on, off, 1, 0.
Yes, that's
all
it.
It can do. Mm-hmm. So what happens is this. Let's kind of bring it all back to the layman's part. All the programmer does is he takes all of that stuff, puts it together in a program, and then the program takes all of those instructions, all of that stuff we just talked about, and puts it in a language that the computer can understand, ones and zeros.
Yeah, that's it.
And it's called compiling. So, the whole thing is you're writing all this code that looks in that just talks about this and talks about that and references this and references that. And at the end of the day, the computer's just going to see it as a bunch of ones and zeros.
That's it.
So, again, the terror that comes with programming is the fact that it looks like a foreign language to you. But understand, to the computer, it's unreadable until you compile it.
That's correct. Yeah. Poor computers, they only understand one thing.
They really, really do. It's amazing that we've created something that powers every aspect of our world, yet it still only exists in 2 states.
Yeah.
Okay.
So let's go over the several types of the programming, because there is more than one type.
Yes. Again, you need to learn these fundamentals in order for us to continue to, programming basics.
Yeah.
So this is all the basic definitions you need to learn.
Okay, so one type of programming is procedural.
Procedural, be like your basic, your Pascal. Basically, you just start at the top, go all the way down. The eventing in RPG Maker is a procedural form.
That's it. Yeah, RPG Maker uses procedural.
The eventing it's procedural. It starts at the top, goes all the way down to the bottom, and then stops. Then there's object-oriented, which is more the direction that programming went with B and C, than all the variations thereof, where you have different pieces, parts of programming that are called and brought together. So you'll have this piece over here talks about the color of the car. This piece talks about the car that Teal is starting. This piece over here talks about the sounds the car makes. All these little pieces, parts that are then called together to make an action happen. So that's object-oriented.
That's object-oriented. Yeah.
In a dirty Sanchez sort of way.
And then you have scripting,
which is kind of like object-oriented, but easier to understand for people who don't have a degree in nerd. Basically. Basically. Scripting is the attempt to make object-oriented programming a little more understandable. Yeah, there's some extra nuances that I'm skipping over. That's way too technical for the purposes of this podcast.
Yeah.
But for lack of a better term, think of scripting as the way that you're going to, the most of the time, interact with the game engine.
Yeah,
most of the time you're going to be using scripting program. Sometimes object-oriented programming.
Sometimes.
Depending on the engine. But most of the time it'll be scripting.
And most of the time it is scripting.
Okay, so now that we've thrown out all the scary terms, we're done with the scary part for now. Okay, let's talk about why. Why should you, a level designer, a composer, why should you, a game developer, learn programming?
It's pretty simple. It's going to help you understand the way this computer thinks.
Yes.
And in turn, that's going to help you know how to critically solve how to do things in your game engine.
So
the point here is your critical thinking.
Yes. Studio Blue's whole purpose is to teach you how to fish instead of giving you fish. We don't teach you how to make a summoning system in RPG Maker. We don't teach you how to make a battle scene transition in Unreal. We teach you how to do a think.
Yeah.
The ultimate critical thinking skill in game creation is programming. If you can understand how programming works and understand how your computer thinks, most of the questions you have about how to do things in your game engine will be solved by you applying that basic knowledge, that critical thinking.
Absolutely.
In our community, and Teal and I have noticed this throughout the years, the people who are programmers have the least questions on how to do things and more questions on why certain concepts are used, why certain best practices are used, but not how to do this.
Yeah.
So,
so it's all about just honing those critical thinking skills,
which we promote. Now, does that mean that programming is easy and anyone can pick it up over a weekend? Not if you've never programmed. No, it's time consuming.
Yeah, you're learning. Basically, you're learning a new language.
Yeah, but, and this is truth, and any programmer out there listening, I hope you agree with us. The hardest part of learning programming is being afraid of it.
Yeah.
The more fear you have of looking at code and going, this doesn't make any sense, I quit, I'm going to go draw pixel art. the more you succumb to that, the harder programming is going to be.
Yeah, you create your own mental block.
Yes.
So we're here to dispel some of that and to help you get over that fear.
Yeah. Dispel it and to demystify the crazy shit that's in programming. And the best way to do that is to talk about the basics, the very basics, the bare bone basics. And we're going to use video game comparisons.
Yes.
So we're going to be comparing it to things within a game, like an RPG or something.
Right.
We'll probably settle on RPGs because that's our favorite game genre, but you can apply this to anything.
Oh, any of them.
Now, we're mainly discussing scripting, like I talked earlier.
Because that's what you're going to be primarily encountering in your game engines you're using today, is scripting.
The vast majority of this can be applied to object-oriented really easy.
Mm-hmm.
I mean, like I said, object-oriented is kind of the big brother of scripting.
Yeah.
Okay,
so when you're learning to program,
yes.
Okay, keep in mind that every language that we have on this planet.
Yeah, every programming language. It
uses different wording, okay?
Right.
And we call that syntax.
Right. So, for example, C++'s syntax may be different than Perl's syntax. I say maybe. They are. Different than JavaScript's syntax. But don't think of it like, oh my god, I have to learn all these syntaxes. What's a good way to think of that?
Think of it as like learning English versus Spanish or versus Japanese.
Right. So, language, in the human language, not programming language, is just a series of rules in which words are laid out to have meaning. There's no difference between that core methodology and computer languages, programming languages.
Yeah.
It's the same thing. So you would arrange a sentence differently in English as you would in Spanish, as you would in Japanese, to accomplish the same meaning. And the word choices would be different. Same thing with a programming language. You would choose different syntax, I say with air quotes, and arrange it differently depending on whether it's C++, C#, JavaScript, etc. But you'd be accomplishing the same thing. So a good way to kind of de-fearify that is to look at it just languages.
That's it. Yeah.
That's it. There are a lot of scary terms, aren't there, Teal, in programming?
Yes, but we kind of broke it down into the most vital four.
Yes.
And if you understand these four terms that we're going to talk about, then you're going to be well on your way to jumping into this.
Yes. Now, I want to go ahead and preface everything we're about to talk about, and I'll mention this again. At the end of all of this stuff, under talking about the basics of programming, I'm going to say something that's going to take most of the fear out of your heart. So if you start feeling a welling fear, stick with it. Trust us. There's going to be one statement I'm going to make that's going to make you feel, oh, really? That's not as bad.
Okay, so let's jump into this. The first term I want to talk about is class.
Yeah. What is a class?
Class is something that exists in your game world.
Yes.
Okay. It's more than a static mesh or a texture. And the class can change as the game does.
Right.
So, for example, a treasure chest.
That's a class, right? An NPC.
Yeah, and a save crystal.
A save crystal, right. So let's go the difference between the two. A tree waving in the wind, with animation, that's not a class. That's a static mesh. However, a tree waving in the wind that the player can cut down, that's a class.
Yeah.
So anything in your game world that can be either interacted with or changed over the course of the game for whatever reason is a class.
Yeah.
Let's go and talk about that NPC thing.
Okay.
You wouldn't have a Bob the Innkeeper class. You would have a NPC class or an Innkeeper class, depending on how specific you wanted.
Right.
We'll just say NPC class.
Okay.
So you wouldn't have Bob the Innkeeper class. You would have NPC class. And you would put that NPC class and make that instance, we've talked about instance, that one moment, that one piece of class right there that's sitting in the inn, you would then say that's Bob the Innkeeper.
Yes.
So you've put a NPC class into your inn behind the counter, and then you're going to say, that's Bob the innkeeper, and he's going to do innkeeping.
Yeah.
You take that same NPC class, and you put it outside, give it a patrol path, armor, halt criminal scum, and you have George the Guard.
Yeah.
So in both cases, Bob the innkeeper and George the Guard are the NPC class. That's their class.
That's right.
You have a treasure chest up at the top of the inn that contains 20 gold. That is the class treasure chest, but that is that chest that holds 20 gold in the inn. You can call it chest A.
Yeah.
Then over in the guard tower, you have one that has an iron dagger. That would be chest B, but it's still the treasure chest class.
Yes.
So that's all that a class is. In fact, a good way to look at it is think of a class like an RPG class. That's a good way to think of it. Here's my class of character. These are my NPCs. This is my treasure chests. This is my save crystals.
That's it.
That's it.
The next term we want to talk about is function.
All right. So you're going to hear this tossed around all the time in programming by programmers. All a function is, I'm going to break it down, is a set of instructions that can be used anywhere in the game world. That's all a function is. Talking to an NPC, that's a function.
Opening the treasure chest.
That's saving your game. Starting the quest. Hey, I've talked to Bob the innkeeper. He's going to go send me to go kill wolves. That from the closing of the dialogue to across the screen, kill the wolves quest begin. That's a function. That's a function. Entering the battle scene for turn-based battle engines.
That's a function.
All that. So anytime you have any set of instructions that accomplish a thing within the game world, it's a function.
The next term is method.
A method is just a function that is tied to a specific class.
Yeah, some languages don't really differentiate between the two.
Right, they'll just say it's a function.
Yeah.
However, if you ever hear a programmer or read of something called a method, that's just a function tied to a class. Like, for example, an NPC idle animation that only the NPC class can have. That would be a method.
That's a method.
Right.
Let's talk about our treasure chest example.
Right.
Within the treasure chest, you have a random loot list.
Right, or loot list generator, or whatever that would say, hey, here's some random stuff that could be in there. That would be a method. Only the treasure chest class can use that. The save screen appearing.
Yeah, that's definitely a method.
UI animation, boom. So anytime you hear the word method, it is essentially a function tied to a class.
Yeah, that's what it is.
Yeah. So for the purposes of, again, demystifying, most of the time you're just going to hear people talk about functions.
Yeah.
Last one, and arguably the most important.
It's variable.
Okay. For those of you who use engines that separate things from variables to switches, stop. Because a variable and a switch are the same thing. What is a variable?
It's all the math stuff that makes everything that we just talked about work.
Basically, any sort of data that can change as the player plays the game, whether they initiate it or the game initiates it or not, is a variable. That includes your switches, like an RPG Maker, those on-off things.
Yeah.
That's just a Boolean variable.
That's all just variables.
Yes, it's all a variable. So let's talk about what type of variables there are.
Okay. So we have NPC stats.
Right. So the class, NPC class that both Bob the Innkeeper and George the Guard are a part of would have things like HP, MP, strength, defense.
Yeah.
That would be, their stuff. Affinity level to NPC.
Yep.
Oh, hell, affinity level to other NPCs, affinity level to factions, affinity level to PC1, PC2, PC3. All variables.
Those are all variables.
What else?
In our treasure chest, the contents of your loot list.
If you note in this case, those might be actual words and not numbers. Variables don't have to be numerical.
Right.
They're anything that can change, i.e. is variable. So, potions.
Or it could be weapons. It could be food.
Yeah. That's all a variable. Variables that can change without the player doing anything at all would be something like the amount of game time played.
Oh, yeah.
Yeah. So that little clock that appears in the lower right-hand corner of most of your games, that's a variable. It just upticks every time the engine ticks 1 second of real time.
That's right.
That's all it
Or,
is.
hey, music volume.
There you go.
That's a variable.
Then that's one the user can set, as well as the game engine, depending on if you want to fade your music in or out, or it's too loud for streaming and you want to push it down to 40%, because why is RPG Maker so loud?
Yeah, I don't know.
Enemy aggro level.
Oh, yeah.
That's a variable.
Mhm.
That's a variable that changes. That's a variable that should change, and you should have a dum algorithm that figures out what the best aggro level is. But that's a variable.
Yeah. And then, of course, your on-off switches.
Yeah.
That's
a variable. When I say Boolean just means on-off, true, false.
Yeah, that's all that
it
means.
is. So
yeah.
for all you RPG Maker users out there, all those switches that are separated from variables are just variables that just say on or off.
Switch is a type of variable.
It's all it is. That's all it is. That's all it is. Okay.
So let's dive into how programming works.
See.
Yeah.
Okay, now this is a reminder. This is going to seem scary, but there's great news at the end of this.
Yeah.
So let's jump into the scary.
Okay.
This is what you, the programmer, are going to do.
The first thing you're going to do is you're going to create your variables that define your game world and everything in it.
Seems counterintuitive. You think you'd make your classes first. Well, you'd write down what classes you want to use. So you have your NPC class, your treasure chest class. But then you would define those variables. Create those variables first. Trust me, programming languages hate it when you try to create a class that has no variables defined.
Yeah.
They go batshit insane. So if you're programming, again, this is not what you would do in your notebook. In your notebook, you would write down an NPC class, a treasure chest class. You'd write that down in your notebook, and then in your notebook, you'd put for NPC class, here's the variables.
Mm-hmm.
But then when you're in your programming language, you would create the variables first. Save yourself some frickin' time.
Yeah.
Game engine, same thing. Then
the next thing, after you put your variables in there, then you're going to create your series of classes for everything in your world. So we talked about the NPC class. We talked about the treasure chest class.
Save crystals. Yeah, choppable trees.
Choppable trees.
So
I love that.
You create all of that. If you're thinking there's going to be a lot of going back and forth between classes and variables while you're creating everything, yes, absolutely. Programmers will start to create the class and go, oh shit, I need this variable that I didn't account for.
Yeah.
Because logic is in depth in programming.
Yeah.
So then they'll go back and they'll define the new variable. So don't worry. There's a lot of back and forth in this stage. Then you get all that made. You get all of it done, and then now you're going to create your functions. Yes. That's going to make all those classes do things. Whatever those things are. You know, chopping down trees, trees falling. Two separate functions, but functions nonetheless. Exactly. And you can combine the functions, too, if it's something that's going to happen constantly. Like if chopping down a tree results in the tree collapsing, combine the functions together. Yeah. You know, you don't have to have, you know, you can combine them, you can nest them, other scary words. Then you're going to start making the game happen, and you're going to call upon those functions as the player plays your game. There you go. Okay, so we just scared the shit out of you. Hopefully not. No. But here's the good news. Here's the great news. The game engine makes most of those variables, classes, and functions work. Most of your work is defining them. For example, in your engine, you would say, okay, I'm defining this class that is NPC. I've created my list of variables that are attached to the class NPC. I'm now going to take this class and put it in the game engine behind the encounter. It's called dropping. I'm going to drop the class, the NPC class, behind the game counter, behind the encounter. It's going to have some default looking mesh that's going to probably look like a mannequin. Yeah. Then what I'm going to do, now that it's in there, I'm going to tell the game engine, here's the mesh. It looks like Bob the Innkeeper. Yeah. Here's the name that appears above his head. Bob the Innkeeper. Here's the dialogue he delivers that I'm writing in. Here's the attachment to the WAV files the voice actor did. Here's his behavior for, you know, certain situations. Here's his branching to give quests or to accept your money. All I am doing is taking the stuff that that I defined and telling the game engine, here's what I want it to do. The game engine does all the crunching for you. So a lot of times, people who have never programmed in a game engine before are terrified of, oh my God, I have to do all this stuff. the beautiful thing is the game engine does the heavy lifting.
Yeah, it does.
You just define and then test your logic. There's this massive misconception, and it's on both ends, that when you're putting stuff into a game engine and coding it, that you're going to open up this code sheet that's just C++, and you're going to have to type in your code. You can do that.
You can.
But most game engines don't require that. So that's one misconception dispelled. The other one is you just drop something into the game engine, tell it it's Bob the Innkeeper, and magic. That's also BS. You know, even simple engines, like, again, RPG Maker, require you to input stuff. So you have your Bob the Innkeeper event. You have to say, this is Bob the Innkeeper. Here's the event in which you talk to him. This is if you talk to him before the town was attacked. Create a new page. This is what happens after the town was attacked. You're doing the same thing in your other game engines. You're not just putting Bob the Innkeeper in there and magic.
Right.
So the two things I'm dispelling is that it's all the work on the coding end and all the work on the game engine end, and it actually meets in the middle.
Yeah. So that's it in a nutshell. That's the very basics of programming.
That's it. So hopefully this takes away a lot of your fear that it's too much, because it's not.
No, it's not. You're breaking things down. For you as a developer, you're breaking things down into smaller tasks, and these smaller tasks is what the engine understands.
Yeah.
What the computer understands.
And then that's the magic.
That's it.
That's the magic.
So let's talk about the cheat code.
Yeah, so there's a cheat code to programming in modern game engines, and it's delicious, and it's called visual scripting. Visual scripting is wonderful. Visual scripting is how people who aren't coders can get into programming. We're talking about things like Unreal's blueprints, the Udon engine for VR chat, whatever it is that Unity's coming out with. I think it's called Bolt. But these are really simple. This just shows that program, all that stuff we just talked about, in a flowchart style format.
Yeah.
It visually shows all the coding and scripting that we just spent the last 30 minutes talking about.
Yeah. The beauty of it is that visual scripting compiles just like everything else.
Yeah.
There's no loss of performance.
No real. I mean, you could have people say,
it's tiny little bit.
Well, it's negligible.
Yeah.
I mean, you would have people that say, well, I don't want to use blueprints because it's not as fast as using C++. Not really. Not really. The player's never going to notice the difference. You know, I mean, unless you're doing massive replication across huge swaths, I wouldn't even take into consideration replications for networking games. Even then, I would argue that you can go just as fast because it compiles it down to machine language.
It does.
Binary. And there's different lingo. Like, for example, the little things that connect the flowcharts pieces in blueprints are called pins. So you have, like, here's your piece of the flowchart that says Bob the Innkeeper says hello, to here's the piece of the flowchart that says here's your dialogue choice. You connect one piece to the next through pins.
Through pins, that's it.
In Udon, they're called nodes, and I think in Bolt they're also called nodes. Same damn thing.
Yeah.
Again, every language has different words that pretty much mean the same
thing.
Here's the beauty, though. Visual scripting, compared to coding, is so much easier to learn and so much easier to fix. Debug.
That's debugging, yeah.
Yeah, if you have a piece of code, long-ass code, that has a problem that's causing a bug in your game, it can take a while to debug it. It can take a while to find and fix the error. If you have something like blueprints, a visual scripting language, it is significantly easier because the engine will show you where it's breaking.
Yeah.
And even though it may return this illegible piece of text saying string function call failed or whatever the hell that means, you can physically see where it's breaking and go, okay, I can kind of work backwards and figure it out.
Yeah.
The escape room game I made for HawkZombie's Jam, Fort of Freedom, all of that logic was done in blueprints. Every single time I ran into an issue, the blueprint popped up where it was where the error occurred, and I was able to work backwards and find out the problem. And
that makes, and it's so much easier on
so
you.
Much easier. I could not have completed that game in the 7 days that I did if I had been coding, as opposed to using blueprints. we have a couple of experiences and understandings of blueprints. I'll go ahead and chat a few up. When I was doing Fort of Freedom,
Oh, yes.
I learned about how to take the subclasses. A class would be a thing like, in Fort of Freedom, a class would be a thing like a key class.
Okay.
And then I would make versions underneath it that were a part of or dependent on the key class, but were specific to various puzzles, like the key that was in the hot coals as opposed to the other keys. The key that was in the hot coals would be called a subclass.
Yes.
So I learned a lot working with these blueprints on how subclasses work in the Unreal Engine, and it was really cool because I can take a class, turn it into a subclass, and while I still have all those properties and cool shit of the class above it, I can now specifically say, okay, this thing right here is very specific.
Yes.
But it doesn't screw up or require me to create a whole bunch of extraneous crap for the class above it. So that was really cool. That was really cool.
Yeah. One of the experiences I had using blueprints was I was scripting. It was a movement. And I had an NPC. I wanted the NPC to walk across a space and sing a song.
Right. So while it was moving, it would play that song.
Right. So I created the movement piece.
Right.
I created the NPC piece.
Right. Now, when she says movement, she's talking about the actor, the class, moving from point A to point B, not the feet moving. That was animation.
That's animation. No.
Right.
Yeah. What Steele said.
Yeah.
And then I also created the dialogue script that you read of the song.
Right.
Later on, I would have added in the WAV file of the voice actor singing the song.
Right. It's a very simple concept, but what it did was, instead of having to create the NPC class, and then create the function call, coding in the function call to move it from point A to point B, she just, she just literally created the little blueprint pieces.
Yeah.
And then, defined the movement, changed the, whatever axis it was, X or Y, I don't remember the axis, and then, moved it over to the other place. And then when she ran it, that sucker just moved. And the walking...
And see, each of the things I created were connected by pins.
By the pins. And if I recall, when you did that, you would adjust the speed several times until the speed of the movement matched the walking animation, so it looked like they were walking instead of gliding while their feet was moving.
Right.
It was really easy for her to fix that because all she had to do was run it, watch what was happening, and then adjust that one little variable inside of the movement speed. The amount of time it takes to get from point A to point B. It was really cool because we are not programmers. We're not coders.
I'm not a coder. No.
But we learned a lot about how the logic of blueprints works. So it was really fascinating. Okay, so now it's time for us to take questions from our live audience.
If you've been watching, remember to use the podcast question feature in our chat.
We have avoided talking about programming for a while because, again, it is the scary part that if you're a non-coder can be terrifying. But when we were doing the research for this, Teal and I did come to the agreement that out of all of the critical thinking things we teach, this is the best for that.
I think so, because it really hones your critical thinking skills. And honestly, you'll be able to apply this concept of critical thinking to other aspects of your life.
Yeah.
And just... It opens doors.
A lot of the stuff that Teal and I do when we're talking in our AMAs and our Game Maker forums, if it's something that we are not specifically educated in at that moment, that very specific thing, we're able to give an educated opinion based on critical thinking.
Right.
So understanding how, this variable of the universe affects this part of our lives, like, for example, entropy. Getting older, we're able to talk about, aches and pains.
Yeah.
Because we're able to take a high concept and distill it to how it affects a low-level thing. Okay, we do have a podcast question.
Okay. This question is from KV Kingdom. What are your favorite resources for learning how to program?
I hate to constantly pimp them out, but Udemy.
Yeah, Udemy.
Vet your courses. Some of those courses in Udemy are crap. Others are really good. So look at one that has a high rating. Look at one, watch the trailer. Look and see what the user reviews are. And I mean, don't be afraid to get C++ for absolute beginners, programming for dumbasses. Don't be afraid to get that. It's not an insult to you. It's if you don't know what to do, choose the most basic one you can find. You can get a book too off of Amazon, but I have tried to learn programming through books. When I first started working for the Laser Shop,
that's right,
I was working in the DirectX library, and I had a very, very hard time picking up the nuances from the various books that I had in my library. But what I did was, in speaking to Kevin and the other guys who worked in the department, in actually reverse engineering code, I was able to kind of get a better idea of how those different function calls worked and the syntax.
Right.
So
nowadays, you would have just gone to Udemy and picked a highly rated course and learned that way.
Right. And reverse engineering is the other way.
Yes.
Reverse engineering is the other way.
Which I do that a lot.
Yeah. Well, that's how you did your thing with the animation blueprints. You looked at a blueprint on a sample project and reverse engineered it. So those two. So a place like Udemy, if you can read, if book learning is good for you, Amazon. And then reverse engineering.
Yeah.
Good question, KV. Okay, we got another one.
Okay, this question is from Firehawk. A bit of a curiosity question. Why would an engine use a different language for stuff like eventing and the engine is written in another?
That is a very good question, Firehawk. I
Yeah.
don't know if I can answer that, but I will try. What he's talking about, for example, is let's say an engine is written in C++, but it uses a C-style scripting language for the eventing. I would assume, based off of, again, my knowledge of how computers work, that you would want to have the game engine written in a language that is as close to binary as possible, because then it compiles quicker. I know I'm speaking highly technical. I'll try to break that down to layman terms.
Okay.
The closer a language is to binary, 101010, the easier it is during the time of compiling to get it to run quickly and optimally, because there's not a lot of steps between taking that language and going to binary.
Yeah.
So I would assume that a game engine would be written in those, they're called low-level languages, in order to make them more effective, while you would go up a step and go into a higher-level language and a scripting language to make it easier on the game developer. Because you can program a game in binary, hex or assembly.
Yeah.
All those are scary low-level things. You can do it. It's going to take you forever, and debugging it's going to be a nightmare. But you can do it.
You can do it.
I mean, I would love to see a person write a game in hex. I would love that.
I'd love to see that too.
I would love to see that. It would be Pong, but easier. So yeah, that's my assumption there, Firehawk, is that the engine itself is going to be written in a lower level language that's easier to compile and closer to machine language, binary.
Yeah.
While the eventing language is going to be more of a script that's easier for the developer to understand. Good question.
That's a very good question.
Very good question. And if I'm wrong, somebody please correct me, either in the comments in YouTube or through an email if you're listening to this on a podcast software. Because I'd like to know if I'm wrong.
Yeah, we love learning too. Trust us.
Let's see if we have any other questions. We got one.
Okay, this one is from KV again. What would you recommend for beginners' first programming language?
Undoubtedly either JavaScript or Python. They are relatively easy to pick up.
Yeah.
I mean, I'm always going to push C++ and C# because that's what I cut my teeth on. But I'm going to be honest, if I had learned on Python and or JavaScript, like really learned the nuts and bolts before diving into actual object-oriented programming, I probably would have had an easier time. It was very difficult for me to pick up C by my, the DirectX C++ by myself. Very hard. So yeah, I would say Python
or JavaScript.
Yes. Hopefully those out there who are programmers will agree. If you're listening and you have a better suggestion for a first time programming language, please let us know. Drop a comment in the comments section.
Yeah.
Because I'd like to be able to recommend the best thing.
Yeah.
Okay, let's see if we have any other questions. If not, we'll go ahead and get done. don't be afraid.
That is the big takeaway we want to give you from here is don't be afraid of programming.
Yeah.
It's basically helping you be a better critical thinker.
Yes, and ultimately from there a better game developer.
Yeah.
You are going to have a lot of times that you're developing your games where you're not going to have anyone be able to specifically help you in that instance. And the first reaction to having a problem with transition to your battle scene, having a problem with the automobile auto-accelerating and drifting correctly, all those things, the cloth physics not working. Your gut reaction is going to be to go onto a forum and say, how do I do this one specific thing? If you've learned the critical thinking skills that come with programming, you're going to be more apt to take a step back and say, why is this failing? Instead of someone help me fix it.
Yeah, and you'll start problem solving.
Yes. And then you'll feel much more fulfilled as a game developer because you fixed a problem instead of having someone fix it for you and waiting for them to fix it for you.
That's it.
Yeah. All right, I am not seeing any other podcast questions, so we can go ahead and start wrapping this up.
Okay.
Any final thoughts on your end, or have we pretty much nailed that code to the floor?
I think we pretty much nailed it.
I agree. If you're listening, let us know your thoughts on this. If you're listening to this on YouTube, let us know your thoughts. If you're listening to this on iHeartRadio, iTunes, etc., again, let us know your thoughts. We are now at the conclusion of this podcast, 2 more episodes away from the conclusion of season 2.
Yeah.
And that is a damn good feeling.
Well, that is.
We have 38 episodes of our podcast under our belt.
Yep.
That is amazing.
It's a good feeling.
It is a very good feeling. So if you're listening to us live, thank you so much. Thank you for the questions. Thank you for the love. If you're listening to this VOD on YouTube or iHeartRadio, iTunes, whatever the hell, Amazon Music, whatever the hell we got it on, thank you again.
Thank you. Thank you for your support.
Yeah, we love you guys very much. All right, so join us next time on DLC Not Included. And remember,
anyone can give you the key, but you have to go through the door.